In this last video of this section, we're going to talk about some of the details that you might need to be aware of with generics. Little things that are nice to know that will help you in this. First, let's talk about an actual definition, because I'm not sure how well I defined it earlier, but generics, the idea of generics is that we have a capability to parameterize our types. So we use that T type parameter when we created our class. Okay, with this capability, we can define a class or a method, and I will show you an example of a method in a little bit. We can define a class with a generic type that can be substituted using concrete types by the compiler. And you saw examples of that. They give an example here of a stack class. We'll talk about stacks in a future chapter. But we did it with teams. We defined a generic team that stores elements of a generic type, and then we can create objects from those types. Why do we want to use them? The key benefit of generics is to enable the errors to be detected at compile time rather than at runtime. We saw that example with the get name on our players. If we have a mix of types in our lists and we try to call a bunch of methods from those types, there is no guarantee that they would all have the correct methods. So we do this to limit our list to the types that we want to have, or to limit our objects to the types that we want it to have, so that we can guarantee some things that will be able to happen with it. And we saw that get name gave us a little red squiggly telling us that there could be a problem with this before we defined our type as something that extended player. But we detected it before we ran our program, and we didn't get a runtime error. So a generic class permits us to specify the allowable types of objects that the class or method may work with, and gives us a guarantee because it does type checking. If we use it in an incompatible object, we'll get that compile error. Let's take a look at ArrayList. We're going back to JDK 1.5. And in JDK 1.5, any Java before that had the ArrayList class, but it did not use a generic type. So effectively, ArrayList always held types of the object class, which meant if you want to do anything with them, you spend a lot of time casting them and doing some checking to make sure they're an instance of the proper class before you tried to cast them, so you could do things with them. So that's important to know, that ArrayList didn't always have the ability to use generics, okay? But later on it was added, and here they're using the E for the generic type. But that got added since Java Development Kit 1.5. We have been able to use generic types with ArrayLists. Okay? That's important to know because of some things that we're going to talk about here. So when you create a new ArrayList, and I showed you an example of that, okay, that is considered using a raw type, which is Java 1.5 and before we could use generics. That is considered using a raw type, and there's issues that can come because of that. It's not a great thing. It's roughly equivalent to saying, hey, my ArrayList can hold any kind of object in the world, and I create a new ArrayList that holds objects. By not using, well, at that time they didn't have a generic type, so ArrayList just held objects, and it took a lot of work to use them properly. So avoid that. Don't use it. Don't create a new ArrayList without a type diamond. Always, when you create the ArrayList object, make sure you have the type diamond. And remember that you don't, I think since JDK 1.7, you don't actually have to put the concrete type in on the right side if you have it in the variable on the left side. Just avoids duplicating code. But you need to have the type diamond when you create the ArrayList object. Okay, and that's true of any generic class. Don't create them without using the type diamond, because then you end up with a raw type and unsafe things can happen. So how does it actually work? Raw types are still actually used behind the scenes. So generics are implemented using an approach called type erasure. That means that the compiler is going to use that generic type information that we specified when it compiles the code, but it erases it after it's done. Okay, so the generic information isn't actually available anymore at runtime, but it compiles the code in such a way that makes it safe. What that does is it makes sure that we don't break older code, because remember that older code before 1.5, you used raw types for everything. It still needs to be able to do that. We don't want to break a bunch of old code. So by doing it this way, using that type erasure, it enables the generic code to be backward compatible with that legacy code that still uses raw types. So we don't want to use raw types anymore, but know that behind the scenes, the Java compiler still does it, but it does it in a much safer manner. Okay. So this is basically what happens. So we have an array list, and we specify that our array list takes strings, but once the compiler does it, it does the array list without the strings, but it automatically adds the casting in. However, we're guaranteed that it works because of the way it does it. So know that we type this, the compiler looks at it like this. That's another way to think about that. And the last thing I want to show you is an example of using a generic type in a method, because I did our examples that we did, we used a generic type for a class. You can also use those for a method. So here we have a generic method, and notice it's public, it's static because we're just doing it in our driver class. The return type is Boolean, but before that we put a type diamond and we say, hey, this method requires a type that extends geometric object. Okay. And then people can pass in 2 objects of that type. Okay. As long as there are certain types of geometric objects, meaning they inherit from geometric object, you can pass in 2 types. Geometric object guarantees that they're going to have a getArea method. And then we're just comparing the areas to see if the 2 objects have the same area. Okay. So here's the type diamond. They're using an E instead of a T, but they're saying that whatever type that is put in here extends geometric object. So up here in our main method, we're creating a rectangle, okay? And rectangle obviously inherits from geometric object. And circle, they're creating a new circle, which also inherits from geometric object. So both of these classes are guaranteed to have a getArea method. And then they're just printing out, are they the same area? And they're calling this equalArea method, passing it the rectangle and the circle to compare their 2 areas. Okay. So that's an example of using a generic type in a method. It's kind of the same thing. I write the method without using a generic type, and then add the generic type in, substitute whatever variable you're using, usually a T or an E, in for your types in the places it's needed. In this case, for the 2 parameters of equalArea, we're substituting them. And that's all we're going to talk about for generics. Make sure you read the chapter and get all the details from the chapter. I covered the highlights and most of the important stuff, but there's other things in there as well.